in an experiment.
We don't know yet.
Why is light so fast?
Like, it sounds so simple.
They had no idea.
But now the data speaks.
I find this not only refreshing, but at some level astounding.
Nature.
Welcome back to the Nature Podcast. This week, the hunt for dark matter in primordial black holes.
And how frog saunas could help in the fight against the deadly fungus. I'm Benjamin Thompson.
And I'm Nick Petrichow. Dark matter is one of the big mysteries of physics. Researchers have a good idea that it exists as they can see the effects of its gravity in things like galaxy formation, but they don't really know what it is or where it is. One popular idea is that certain black holes could be made up of some amount of dark matter. These primordial black holes would have formed in the very early universe, and if they exist and have a lot of dark matter, then they would be massive, and so we should be able to see some traces of them. Whilst we wouldn't be able to see these black holes directly, they would bend light around them, in a way magnifying it, in a process known as gravitational microlensing. This would, in effect, brighten stars as the black holes pass in front of them, giving us a rare opportunity to spot them. If they contained a lot of dark matter, they would be especially massive, so this brightening would last a long time, years even. These black holes could also explain another mystery in physics. Some gravitational waves that have been detected by LIGO and Virgo indicate that there are huge black holes colliding together. These primordial black holes could be the culprit. So to look for these microlensing events, researchers have been scouring through a decades-long dataset of observations in a nearby galaxy called the Large Magellanic Cloud. The idea is that if they find primordial black holes that bend light around them for years, then they may have found where some of that dark matter is hiding. I caught up with one of the team, Mróz, and he laid out for me how they went about it.
So, if dark matter was composed of very massive black holes, such as those detected by LIGO and Virgo, we expected to find hundreds of microlensing events with very long timescales. Microlensing events would last up to several years. So this was the idea, to search for very long duration brightenings of stars in the Large Magellanic Cloud.
I mean, it sounds almost straightforward in a way. You're looking for these events, these little brightenings when these sort of cosmic magnifying glasses go past. But the sky is quite big, I reckon. So how hard is it to detect something like that? Because as I understand that you had like 20 years of data for this.
Right. So first of all, probability of microlensing is very low because you need those three objects, observer, the source of light, and the lens, to be almost perfectly aligned. So the probability of such chance enlightenment is very small. So typically less than 1 in a million of stars is microlensed at the time. So first of all, you need to observe dozens of millions of stars to try to find any microlensing events. So you want to observe very dense regions of the sky where you have many stars. You also need some patience because you need very long observing sequence. So our project, it's been observing the sky for more than 30 years. So as you can imagine, its database is big enough, and we use those observations to search for those very long timescale microlensing events. So we use observations of about 80 million stars.
I mean, that is a huge data set. How do you go about sort of, I guess, searching through it to find these microlensing events?
Well, I would say it's quite easy because most of the stars that we observe are constant. They don't change at all. So what you are trying to find are objects which change brightness in a very specific pattern. So basically, in the first step, you try to find objects that are brighter during some part of observations. And then you try to see if this brightness pattern matches what you expect from theory. And using very simple selection criteria, you can select objects which behave as you expect for microlensing events. So we started with a sample of almost 80 million stars, and at the end we end up with 13 microlensing events in our dataset. So it was quite, well, for me it's easy to find such objects in our dataset, but of course it takes a lot of effort to make the thing work and work well.
And how do you sort of distinguish these microlensing events? Because I guess they could be other things like stars or other massive objects in the sky. How would you know, for example, if it really was a primordial black hole or something like that was causing the microlensing?
With our current observations, actually you cannot distinguish, but we can say that if entire dark matter was composed of black holes, we should have detected much more microlensing events than we actually did. So, for example, if dark matter was composed of 100 solar mass black holes, we should have detected about 100 microlensing events in our dataset. If dark matter was composed of 10 solar mass objects, we should have detected about 250 microlensing events, which can be compared to 13 events that we actually have detected.
So you have like this idea of the number of these events that you should see, and then you compare it to the actual, and that gives you an idea of the dark matter.
Exactly. So we have an idea about the number of microlensing events that we should see and about the time scales. And we compare the numbers, the time scales with observations, and from that we can infer limits on dark matter.
So you had then these 13 microlensing events that you observed, but as I understand it, they were all quite short in terms of the timescales, so they wouldn't really explain very massive things. So I guess I'm wondering, what would you say is the sort of main result conclusion of your paper?
Our key finding is that the number of very long duration microlensing events that we see in our data is 0. And so we can confidently say that very massive black holes cannot comprise a significant fraction of dark matter. Less than 1% of dark matter is composed of such black holes.
And so what do you think this means for our understanding, I guess, of how the universe works? I guess that's such a broad question.
Right, so this idea that primordial black holes may form dark matter is really popular. I mean, the first paper that postulated that idea has literally hundreds of citations. So I think our work clearly demonstrates that this is like a wrong direction. Primordial black holes cannot form a significant fraction of dark matter. So people should change their ideas and try to look for some other things. In my opinion, it's just at that end, and now we should try to find another explanation for the dark matter and for the gravitational wave events that we see with LIGO and Virgo.
Yeah, because I guess that's the other question. There were these massive collisions that have been detected. So what might be the source of them?
So I think there are like two competing ideas currently. Of course, I think we ruled out the primordial black hole idea. The other possibility is that very massive black holes may have formed from stars with a small amounts of heavy elements. And we think that such stars may give rise to very massive black holes. The other idea is that massive black holes could have formed from smaller black holes that merged into bigger ones.
And so what would you say are the sort of next steps then for you? Are you going to be hunting for more black holes, different kinds of black holes?
Well, we plan to search for planetary mass black holes. So this is the other idea, that primordial black holes can have any mass. And some people say that they may have planetary masses similar to that of Earth or Neptune. And we also have some observations that we collected recently in the past 2 years, and we want to analyze those datasets to see if we can detect very low mass black holes.
That was Mróz from the University of Warsaw in Poland. For more on that story, check out the show notes for a link to the paper.
Coming up, a simple solution to tackle a deadly fungus that's been decimating frog populations. Right now, though, it's time for the research highlights with Dan Fox.
The pressure of the deep ocean would crush many creatures. but some species of comb jellies seem to handle it without issue, despite their squidgy bodies. Now, researchers think they know how, by using cells full of special fat molecules. To understand how the jellies can survive the extreme pressures thousands of meters below the ocean's surface, biologists collected samples of 17 species from varying depths. They then analysed the structures of fat molecules known as lipids that make up their cell membranes. They found that the comb jellies from deeper areas were more likely to have lipids that form curved layers at low pressure. By contrast, species that can live in shallower waters had lipids that formed flat sandwiches, similar to those of organisms living on Earth's surface. To test what effect the lipids may have, the authors engineered bacteria to produce membranes containing curved lipids, and saw they were better able to survive at high pressures than non-engineered bacteria. The authors say that these lipids could explain why some deep-sea creatures disintegrate when brought to the surface. Take a deep dive into that research in Science. Mothers who received substantial monthly cash transfers as part of a study of low-income households spent more time and money on their children than those who didn't. Researchers selected 1,000 mothers living below the federal poverty line in 4 US cities to receive a monthly cash transfer for several years after childbirth. Some received $333 a month, while others received just $20. After 3 years, mothers in the high cash transfer group were up to 8.2% less likely to live in poverty than those in the low cash transfer group. They were also seen to spend around $68 more per month on toys, books and activities for their children, and an average of 11 minutes more per week on early learning activities. Meanwhile, high transfer families' spending on alcohol and cigarettes was similar to, or less than, that of low transfer families. The results suggest that cash infusions to parents can directly benefit children's early environments. Read that research in full in Nature Human Behavior.
Next up this week, we've got a story about a simple, cheap and effective way to help frogs fight back against a deadly disease. Back in the 80s, researchers studying frogs noticed something mysterious. The animals were disappearing.
A lot of people were doing repeat field studies every year, going back to the same populations, and then suddenly, one by one, they were meeting up at conferences and saying, my study species is vanished, I don't know where it is anymore. And it wasn't abundantly clear what was happening, but it was happening really fast.
Around the world, formerly vibrant populations of these amphibians were suddenly going silent. And no one knew what was going on. It wasn't until the late 90s that a culprit was identified: a fungus.
No one was really thinking like a fungus, and it was a fungus in this group of fungi that are not typically pathogens. They typically just eat dead stuff like most fungi do, but this is the pathogenic chytrid.
This is Anthony Waddle from Macquarie University in Australia, who studies this fungus called Batrachochytrium dendrobatitis, often known simply as BD or chytrid. It's thought to have originated somewhere in Asia before it spread around the world through animals being traded as pets. And while it doesn't affect all frogs equally, as a pathogen, the fungus is often brutally effective.
Our conservative estimate is 90 species extinctions, and hundreds of other species have declined. And really, this is an ongoing problem. There are still populations blinking out. There are still species going extinct. No other infectious disease has ever caused this much devastation to biodiversity. It's the worst infectious disease ever recorded. So when you look at the challenge ahead of you, it's kind of immense.
One of the reasons the challenge of tackling this fungus is so immense is that once it's in an environment, it's virtually impossible to get rid of. So far, the most effective way to protect severely affected frogs has been to keep and breed them in captivity, treating any that get infected with antifungals. But Anthony and his colleagues have come up with an, on the face of it, simple and inexpensive way that could help some frogs clear an infection, which they describe in a recent Nature paper. Their method relies on BD's Achilles heel.
The fungus really struggles in high temperatures. In frogs, it really struggles at even moderately warm temperatures. So if you make a frog 26 degrees, the fungus is not going to kill them. It's going to struggle.
It's long been known that keeping a frog hot keeps the fungus at bay. And this helps explain the seasonal waves of infection seen in some locations. In the summer heat, the fungus practically disappears, only to rebound and tear through populations with a vengeance in cooler months. And this got Anthony and his colleagues thinking. Could they use this knowledge about the fungus's weak point to come up with something to give frogs an edge? Evidence suggested that frog populations who had access to areas that are warmer, to hotspots in the wild, can persist in the face of BD. But these hotspots can be few and far between in winter. To overcome this, the team decided to build their own.
And the old saying, if you build it, they'll come. And we were hoping that was true. We just built different types of prototypes and came up with one we thought would be really good. And then we went with that for the study.
And their final design, well, it might not win any architectural awards. Let's put it like that.
Oh, it's horrendous looking. No, it's all right. What I like about it is it's something that you might find in your backyard. So all it is a pile of common masonry bricks that we painted black. They're arranged in kind of a high-rise apartment structure. And we put a greenhouse that we bought from Aldi over the top. That holds in humidity, which is important for frogs. Obviously, their skin can dry out. And then while the bricks are absorbing heat from the sun, the greenhouse kind of holds it all in.
The bricks in the frog sauna have holes where the animals can chill, or perhaps more accurately, warm, even on a relatively cool Sydney winter's day.
Even on a day that's, 15 degrees outside and sunny, it could be well over 28 degrees, 30 degrees in the greenhouse. We're lucky in Sydney, we have lots of sun, and winter is no exception. So they perform quite well in providing these high temperatures.
And these saunas were pretty affordable. It turns out the first batch of greenhouses the team bought from the budget supermarket chain were on sale. And Anthony reckons the cost to build one comes to around $70 Australian. But how effective was this setup at helping frogs clear the chytrid fungus? To find out, they tested it using an Australian frog that was once a common sight in people's gardens on the east coast of the country, the green and golden bell frog. The male of the species has a call that sounds a bit like a moped changing gear.
They're a fat frog, cute. They are big for a frog. They probably fit in the palm of your hand. They are amazing colors, and they're a very explosive breeding frog. They can have 10,000 offspring at once. And it's amazing they haven't evolved resistance or just bred their way out of being in trouble. But here we are.
Like so many frogs, these bell frogs are susceptible to BD, and it seems to have played a significant role in their decline.
Since the arrival of BD, 90% of its populations have vanished.
Before they hit the sauna, frogs were tested in the lab. Evidence suggested that these frogs like it hot, but the team had to test it. When the animals were given the choice of what temperature they could hang out at, they would move to an area where it was on average about 29 degrees Celsius. To see what effect this had on their ability to shake the fungus, the team infected frogs and either artificially kept them at this high temperature or allowed them to choose their temperature once again. The approaches had differing results on infection severity.
The frogs that could move around and change their body temperature however they want rapidly lost infections, which was surprising because we thought, if we put the frogs really at high temperatures, it should just kill the chytrid right away. But it was the frogs that could move around, even if they were on average colder than the ones at the high temperatures, they lost it much faster. Having the ability to change their body temperature at will was the best thing for them.
This was in marked contrast to frogs kept at lower temperatures, who all experienced much more severe infections. What's more, other experiments showed that infected bell frogs who'd been heat-treated were more resistant to a future infection. In a sense, they'd been inoculated. But would lab effects be seen when the frogs had access to the saunas outside? Despite their rustic appearance, the frogs loved sitting in them, and when the team compared how infected frogs that sat in uncovered and hot saunas fared compared to those who had access to shaded saunas that were cooler, the results were stark in terms of infection levels.
In terms of percentages, maybe at any given time, 10 to 100 times lower infection in the frogs that had access to the hot shelters. And we'd expect this to translate to real differences in survivorship. And, we have that evidence from the lab that it's like 22 times greater chance if you've survived an infection to survive a subsequent one. So I think the real benefit of these is not just that initial time they survive. It's that even if this frog is cold the next winter, it could have that resistance. And they enable frogs to do that themselves. We don't have to intervene.
Taken together, this vaccination-like effect, alongside providing the frogs with a place to clear an infection, could be a powerful tool in the fight against the chytrid fungus, says Anne Savage from the University of Central Florida in the US, who's written a News and Views article about the research.
So when I saw this study, I thought this is one of those examples of a very elegant piece of scientific research that is so obvious and intuitive when you read it and you think, why didn't I do that? And I actually do know of some herpetologists that have in casual ways done these sorts of things as a practical solution, but no one has published it as scientific research and done it in such a rigorous way that clearly demonstrates the benefit of providing warm refugia for frogs. So I was really jazzed to see it because it's probably the least expensive and most beneficial practical management tool that we could start using.
And while this research shows the benefits of this approach, Anna wants to know how many frog species it could benefit and exactly how it works. At the minute, it's one species, and one that's quite happy at warm temperatures.
So we would want to repeat this study across different types of frogs in terms of their genetics and evolution, and then also in terms of their ecology. So the paper does a really good job of stating directly that if it's a frog that prefers cooler temperatures, this whole project of the refugia and the immunization, we don't know if it would work under that scenario. And then it is wonderful that we have this practical knowledge of some kind of functional vaccination. But I do think it's still very important to understand the mechanism. We already have a number of studies that show there's all different types of immune responses being stimulated or not being stimulated associated with different types of disease outcomes. I think it's really important that we do start honing in on mechanistically how do frog immune systems work and how much of that variation is because of different environments, genetic variation present in the frogs, and maybe even unique modes of immune function in frogs that we don't know anything about.
Anna hopes that understanding how some frogs defend themselves against BD infection and whether the saunas help boost immune activity in others could ultimately lead to genetic engineering strategies to introduce resistance into imperiled frog populations. But immune systems are complicated, and that's a long way down the track. Anthony is cognizant of the limitations of his work, but knows that right now options for frogs are limited.
We have so few positive stories in chytrid and conservation that this, to me, is so exciting because we can help one endangered species.
And Anthony is using the saunas to help the green and golden bell frogs both in captive and in wild populations. For example, setting up saunas in Sydney Olympic Park, home to one of the last large bell frog populations in Australia. He's also hoping that people make their own to put in their gardens, and is putting the build instructions out for others to follow. But while this method is unlikely on its own to reverse the decline in a group of animals facing a devastating disease, he's hopeful it could make a difference, even if it is a somewhat unorthodox approach, the success of which was somewhat of a surprise.
I said, really? A pile of bricks after all this time? This is what's going to work, is just this. No, I guess I should spin it as it's elegant and simple, but it's just a pile of bricks. At the end of the day, this is not at all what I thought was going to make a difference. I was thinking some high level, really complicated solution to the problem. But yeah.
Anthony Waddle there. You also heard from Anna Savage. To read Anthony's research paper and Anna's News and Views article, look out for some links in the show notes.
Finally on the show, it's time for the briefing chat, where we discuss a couple of articles that have been highlighted in the Nature Briefing. Ben, what have you been reading this week?
Well, Nick, as I'm sure you are very much aware, here in the UK, we are heading to the ballot box tomorrow as this show goes out, so the 4th of July, for a general election.
Absolutely. I've been getting all the flyers from all the different parties, and I'm guessing this is going to be an important one for science as well.
Yeah, so polls suggest there's going to be a change in government, and the Labour Party is predicted to beat the Conservative Party, the current party of government, who have been in power for over a decade, 14 years. And since they came to power, a bunch has happened to science. And there's a recent article in Nature looking at what a potential leadership change could mean for science moving forward. Now, of course, there are other parties fielding candidates in the election besides the Conservative and Labour parties, but this is the current government and the potential future government. So these are the ones this article concentrates on.
I guess a lot will be on the cards. I know the researchers have been interested in the fallout of Brexit and immigration. So, what are the key things that are going to be important in this election for scientists?
Well, you mentioned immigration there, and I think one of the most talked about issues throughout the election campaign has been immigration, and scientists are among those who've been critical of recent restrictions on UK visas that were introduced by the Conservative government. Now, in January, the government banned most international students from bringing their families to the country, and increased the salary threshold for skilled worker visas by 48%. And it's currently £38,700, which is almost $50,000. And I think scientists have voiced fears that this will make the country increasingly unattractive to overseas researchers who want to work and study in the UK. And in addition to that, the number of international applicants to UK universities has dropped quite a large amount, 44% between January and March, compared to the same period in 2023. Now, this is having an effect on the funding that institutions and universities have, because they are bound by a limit to the tuition fees that they can charge domestic students. So there could be a significant gap in funding there. And people are saying that it's really important that whoever forms the next government understands that being able to recruit international students at all levels, so, undergraduate, PhD and masters, where a lot of these students come in to study, put a huge amount of money, billions of pounds potentially, into the research system each year.
And so I guess what are the sort of main parties planning to do about some of these issues?
It's an interesting one, and there's a lot of questions that remain to be answered that will presumably come out in the fullness of time. The Conservative Party will stand by the tougher policies in their manifesto and even say they will go further if elected. While the Labour manifesto, it doesn't really go into details on their plans for migration and visa rules, although they do say they would, quote, reform the points-based immigration system so that it is fair and properly managed. But there's a lot that's unknown about, what this actually means.
Right, and I think another thing that many people will be wondering is, what are the parties planning to do in terms of funding science? Is there going to be more or less funding with different parties? Have they said anything about this?
Well, right, and we often talk about funding on the podcast because it is crucial for the enterprise of science. And public spending on research and development, so R&D in the UK, rose quite considerably from around £13 billion in 2011 to £16 billion in 2022. And the Conservatives have said they want to increase this to £22 billion by 2026, Now, the country spent around 2.9% of its GDP on R&D in 2021, which is the last year for when this data was available, which is higher than it was in 2010, but still lower than many other nations. And of course, there are always going to be calls to increase this. Now, Labour's manifesto doesn't feature a detailed budget or specific funding pledges for science, but the party says that it wants to scrap short-term funding cycles for key R&D institutions, and they're in favour of 10-year budgets. Now, some people say that they would welcome that change because it brings stability, but it's not entirely clear what that means. And, the devil's in the details, of course.
And another big priority for the world, really, going forward is climate change. How do the different parties stack up when it comes to tackling this issue?
Again, a lot's been said, but it's interesting to know how it shakes out. So last year, Rishi Sunak, who is the current Prime Minister and leads the Conservative Party, he rode back on several of the government's green targets, moving the deadline for selling petrol and diesel cars from 2030 to 2035. But the UK is legally bound to reach net zero carbon emissions by 2050 under a law that it passed in 2019. Now, the Labour Party says it will create a new publicly owned company, Great British Energy, and it says that it wants to double onshore wind, triple solar power and quadruple offshore wind by 2030. The Conservatives say that they are committed to delivering net zero by 2050 and also would triple offshore wind power. And both parties say they will invest in carbon capture technologies and scale up nuclear. So it is something that's at least being talked about in the manifestos. And again, it sounds like a broken record, but we'll find out in a couple of days, I suppose, what is going on. And there's one other topic as well that I think is worth bringing to the table, and something that we've covered a fair bit on this podcast, and that is AI research,
of course,
Nick. And of course, the growing AI sector is likely to be an issue for any government. Now, both Labour and the Conservatives have committed to boosting the country's involvement in AI, which I think everyone is of the mind will have wide-ranging impacts for science and for regulation. The Conservatives say they would invest over £1.5 billion on large-scale compute clusters to help take advantage of the potential of AI and support research into its safe and responsible use. The Labour Party says it will support the development of the AI sector and would address ethical and regulatory concerns to make sure things are developed in a safe way. So again, it's a sector that we know is on the rise, so lots to understand there and lots of places to interact with it and potentially help steer it in a direction that is considered the right one.
Well, it's all at play, I guess, at the moment. But for now on the show this week, I've got a story of one I was reading about in Nature, and this is something that we've also talked about quite a lot. It's moon missions, and this is about China's moon mission to collect rocks from the far side of the moon.
Right, the far side of the moon is big business, right? Or it certainly will be. I think there's a bunch of missions planned, but China have been there, and I know this story. They've done something special, right?
They've certainly done something special. So this mission, the Chang'e 6 mission, is the first mission to collect rock samples from the far side of the moon. So completely different to anything that we've had before. All the missions in the past have collected from the side of the moon that we can see, the close side of the moon, I guess. And so this is the first time this has happened. So scientists are pretty excited to get their hands on these rocks. They've collected 2 kilograms of them, and so far, all that's happened is that earlier in June, more than 200 scientists from Chinese universities and institutions came together and voted on what they think the priorities should be for what they do with these moon rocks. And the top question is to explore why the moon's 2 sides are so different. And then they also want to understand like what the composition is of these sort of deeper lunar structures and how the basin where the moon mission went to, how this was formed.
I mean, I think it's worth saying, what an achievement this is. We have covered on the show, multiple times, moon missions that haven't gone well, that have fallen over or that have crashed onto the surface or that, contact's been lost. So a successful moon mission is something of a rarity at the moment.
Absolutely. And there's a quote in this article from an astronomer from the Harvard-Smithsonian Center for Astrophysics in the US. And they said that this shows that China's ability to carry out highly complex missions at lunar distances is robust. And this could be really important for future moon missions. It is incredibly complicated to get a craft to the far side of the moon, to navigate it, to control it, to make sure it lands, and then also it returns as well. And obviously that'll be very important if we ever send humans to the far side of the moon, which I think is in the works as we speak. And just to give you a bit of context here as well, this was quite a perilous return mission because the lander had to land on the far side of the moon, which was hard to get to in the first place. Then it had to launch with the samples, reconnect with the re-entry module. Then the re-entry module had to return to Earth. And then because it was going so fast towards Earth, it had to skip across the Earth's atmosphere to slow it down and then slow-ishly come down towards Earth and used a parachute as well to land. And at any point, something could have gone massively wrong here. So to actually get this done is, as you say, quite an achievement.
The rocks and the regolith, right, the lunar soil, I suppose, is the kind of headline story here. But presumably there was other stuff as well. Will researchers learn anything else about the far side of the moon?
Yeah, so the craft was carrying a couple of different instruments from different teams around the world as well. So one of them was from ESA, the European Space Agency, and it was a negative ions at a lunar surface detector, which detects negative ions, as it turns out. And so using this device, negative ions were detected on the moon for the first time. And by studying these, it's hoped that scientists will understand the lunar surface environment and help them design robots and crewed missions to sort of go around the environment a bit better. There was also a French instrument called the Detection of Outgassing Radon, or DAWN, and they said they recorded 19 hours of good quality data using this device. So they're going through that data at the moment, and hopefully they'll find something interesting from that. But yeah, there's been quite a sort of international cooperation as well as part of this mission. And going forward, there's more Chang'e missions planned. So there's Chang'e 7 and Chang'e 8, and these are much, much more complex. They are looking to go to the lunar South Pole, where there's thought to be oxygen and ice that could be used to make fuels and stuff in the future, and maybe even enough sort of materials to establish a long-term human presence.
Yeah, I think if listeners go back and listen to the long read from last week, they'll hear about NASA's sort of practice missions in Arizona to do geology and what it might be like to do geology on the lunar South Pole ahead of the Artemis mission in 2025, I think. So check that one out.
I think it's certainly safe to say it's a good time to be a moon scientist because there's a lot going on and a lot planned for the future. But I think that's all we've got time for on the briefing this week. Listeners, for more on those stories and for where you can sign up to the Nature Briefing to get more like them, check out the show notes for some links.
And as always, you can keep in touch with us on X. We're at Nature Podcast, or send an email to podcast@nature.com.
And if you like what we do, you can leave us a review where you get your podcasts. I'm Nick Petrichow.
And I'm Benjamin Thompson. See you next time.